Welcome to Pristine Maths Club. Like, comment, and subscribe. We shall be looking at parallel and perpendicular line. Let's look at a parallel line. Let M1 be the gradient or slope. The gradient or slope is the same thing. Sometimes we use them interchangeably of a line AB. And M2 be the gradient or slope of line PQ. Then we'll know that the gradient of AB will be equal to the gradient of PQ. Let us look at this. Suppose we have the Cartesian plane like this. Okay. We have the parallel line AB. Okay. You have the parallel line PQ as well. Okay. The two lines are parallel. So the gradients of the two lines, let the gradient of AB be M1. Gradient of PQ be M2. So the M1 will equals to M2. Note that the slope of the AB will equals to the slope of PQ. Now, if it's a perpendicular line, let M1 be the gradient or slope of line AB and M2 be the gradient or slope of line PQ. Then M1 times M2 is equals to -1. Okay, we can also say that the M2, the gradient of PQ, will be equals to -1 over the gradient of AB, which is M1, by dividing everything by M1. Let us look at this as well. Suppose we have the y-axis and the x-axis Cartesian plane. We have a line PQ, and we also have, a line AB rather. We also have a line PQ that is perpendicular to line AB. When it is perpendicular, it will make angle of 90 degree at the place they meet. So that place is 90 degree as we have seen it. Okay, that is when we say the two lines are perpendicular. And the slope of AB, which is M1, and the slope of PQ, which is M2, they will be related by this. M1 times M2 will be equals to -1. Okay, let us look at the example on this. Example: if lines AB and PQ are parallel and line AB is 2y plus 3x is equals to 5, find the gradient of line PQ. In this situation, we are given a line AB. Okay, to do this, we have to get the slope of line AB, and to get that, we have to make the y the subject of the formula. So it will be 2y. Now we take the 3x to the other side. We have -3x plus 5. Okay, we divide everything by 2. So we have the y to be equals to -3x over 2 plus 5 over 2. If we recall the general equation of a straight line, which is y is equals to mx plus c, we will see that the coefficient of x there is the m, is the gradient, which is -3 over 2 in this case for our line AB. So we have the gradients for the line AB now to be -3 over 2. Okay, and for the two lines to be parallel, okay, let's say the gradient of line AB is M1. Okay, for parallel line, we know that M1 will be equals to the M2. Okay, so gradient of line PQ now is therefore is also equals to -3 over 2. Okay, so because the two lines are parallel, that's about that. Let's look at another example. If lines AB and PQ are perpendicular and line AB is y plus 2x is equals to 5, we have to find the gradient of line PQ. The same way we did that one, the line given to us, which is line AB, we make y the subject of the formula. But in this case, the relationship between the two gradients, that is AB and PQ, multiplication is equals to -1. So let's the AB as gradients of M1. So we make y the subject of the formula for the equation given to us. From there, we'll be able to get the gradient of AB. So make y the subjects of the formula. So y is equals to, you have the -2x when you take that one to the other side, okay, plus 5. Okay, by the general equation of a straight line, you will see that the y is equals to the mx plus c, and the coefficient of x there is the gradient, which is equals to -2. Suppose the m1, which is the gradient of AB now, is equals to that -2. Look at the relationship now. We want to get the gradient for line PQ. Okay. Okay. You say that the m1 times the m2 is equals to -1, as I've rightly said before. So the m1 is equals to -2 times the m2, which is equals to -1 there. So we divide everything by -2. So we have the gradient of PQ now to be equals to 1/2. And that is for that. The lines AB and PQ as stated below. Determine if AB is parallel or perpendicular to PQ. Okay. Now we write our A and B. Okay. Let's the slope or gradient of AB be M1. Okay. And the M1 now will be equals to Y2 minus Y1 over X2 minus X1. Okay. And that is X1, that is Y1. Okay, X2, you have the Y2. You can use them interchangeably. The X1 Y1 can be X2 Y2. Okay, the gradient now, you plug in your Y2 minus Y1, which is 3 minus 1. X2 is 4, S1 is 1, 4 minus 1. So you have 2/3 as your final answer for that. We now look at for the PQ now, which is already given for question A. The same thing, we say that let the gradient of PQ be M2. Okay. M2 is equals to Y2 minus Y1 over X2 minus X1. Okay, this is X1, this is Y1. Okay, this is X2, you have Y2. Okay, so we put everything there. Okay, so the M2 now will be equals to, you have the Y2 is equals to 8 minus the Y1, 6 over, for X2 is 5 minus 2. Okay, you now have your M2 to be equals to 8 minus 6, you have 2, 5 minus 2, you have 3. Okay, we can now see that M2 is 2/3 and M1 is also 2/3. Both are the same thing. So in this case, for the A, we'll say that the AB is parallel to PQ. since the gradient of AB and PQ, they are the same thing. So that is how to go about that. Okay, so let line AB is parallel now to the other one. Now we look at the second one, B, here now. Okay, so let's look at AB in this case. We have the x1, y1. Okay, we have the x2, you have the y2. Okay, for the AB now, suppose we say the m1, the gradient of AB is m1 now. In this instance, we write the formula for the gradient as we have known: y2 minus y1 over x2 minus x1. Then we plug in all our values. You have 2 minus minus 1. Okay, over 3 minus 5. You have 3 minus 5. Okay, so at the end of the day, you have the m1 to be equals to 2 minus minus 1, that is 2 plus 1. You have 3. Okay, that is 3 over 3 minus 5 is minus 2. Okay, we look at that also for PQ. Okay, we look at that for PQ as well. Okay, that is x1, y1. We have the x2, we have the y2. Okay, and we write the formula down. The gradient of PQ will have to be m2. So we have y2 minus y1 over x2 minus x1. Okay, in this case, we have the 6 minus 4 over the 5. We have the 5 there for the x2 minus 2. So 6 minus 4 now. We now have the second gradient to be m2. You have 2 over 3. Okay, you have the 2 over 3 in this case. And for it can be parallel because they are not the same thing. M1 is not equals to M2. But for the perpendicular, M1 times M2 is equals to minus 1. So let us check. M1 is 3 over minus 2. M2 is 2 over 3. Let's cut the 2. 3 here 1, 3 here 1, 2 here 1, 2 here 1. So the answer is now equals to minus 1. So in that case, we will say that line AB is perpendicular to PQ. Example, find the equation of the straight line which passes through the point this and is perpendicular to the line. Okay, to find this one here, we have to know, we say it's perpendicular. For perpendicular line, we should know that the m1 times m2, that is the gradient of first one times the gradient of second one, will be equals to minus 1. We just finished that. Okay, so we find the gradient of the line first, the first line. And to find the gradient of the first line, we make y the subject of the formula. So we now have minus 4y is equals to minus 2x minus 3. We divide everything by minus 4. Minus 4 by minus 4. So this one cut this. We now have it cut it. So we have the y to be equals to x over 2 plus 3 over 4. Okay, x over 2 plus 3 over 4. Okay, so now you call the equation of motion general equation of a straight line y is equal to mx plus c. Coefficient of x is usually the what? Our gradient. So in this case, we say that the m is equals to 1 over 2, which is the gradient in this instance now. And for two perpendicular line, if the m1 is equals to 1 over 2, we should know that the line that is perpendicular to this, they will have this relationship with the gradient. So we'll try to get the m2 now. Okay, times m2 is equals to minus 1. So the m2 now, we multiply this one by 2. Okay, over 1. This one by 2 over 1. So the second gradient for the second line that is perpendicular to this line now will now be m2 is equals to minus 2. Is equals to minus 2. So in this instance, that is the gradient for that straight line. But it passed through the point minus 3, 5. So the this point now will become the x1 and y1. But let us recall the formula first to solve the equation of a straight line. We have y minus y1 is equals to m into bracket x minus s1. The minus 3 is x1, as you have seen there. Okay, 5 is y1. Okay, we plug in everything in this. Okay, we plug in everything. So we now have y minus 5 is equals to m, which is minus 2 into bracket x minus minus 3. Okay, y minus 5 now is equals to minus 2 into bracket minus 2x. Okay, minus 2 times plus 3, because minus times minus 3 is plus 3. So you have minus 6. So in this instance, you get y is equals to minus 2x minus 6 plus 5. Y is equals to minus 2x minus 1. So that's the equation that is perpendicular to the line given to us there. Okay, let's move on to the next question. Okay, find the equation of a line, of the straight line, which passes through minus 3, 5 and parallel to this line. You can see now the one we did is perpendicular. This one is parallel. So we'll get the gradient or slope of this line, and it will be the same thing for the other line. So let's get the gradient of this line. Okay, and to get the gradient of this line, we'll write the entire equation down, and we'll try to make the y the subject of the formula. Then we compare it with the general equation of a straight line. And to do this, you have 3y is equals to, you have the 5x, okay, minus 2. So we divide everything by 3, by 3, by 3. So we have y is equals to 5x over 3 minus 2 over 3. So the equation of a straight line now, y now is equals to mx plus c plus c. Okay, the coefficient of x here now, which is equals to 5 over 3, is the what? Is our slope. So for parallelism, M1 is equal to M2. So M2 now, for the line we want to get the equation, we also equals to 5 over 3. Okay, since it is parallel. And we should recall the formula that we use for the equation to solve the equation of a straight line. Or x minus x1. We already know the formula. We are familiar with it now. So this is our x1. That's minus 3. Y1 is 5. We put everything inside it. So we now have y minus 5. Okay. We have y minus 5 is equals to 5 over 3, which is m2, into brackets the x minus 3. Okay, we solve this now. We solve this, and we now have y minus 5. Okay, is equals to 5 over 3 x plus 3. We use 5 over 3 to multiply everything inside. So we have y minus 5 now is equals to 5x over 3. 5 over 3 times 3 will give us 5. Okay, so in this case you can multiply. We take this one to the other side. 5x over 3, 5 plus 5 plus 10. We take minus 5 to the other side. Okay, we have 10. So we can multiply through now by 3. So we have 3y is equals to 5x plus 30 in order to have not to have a fraction there. So this line now is parallel to the line given to us. Okay, you can see they have the same slope. Let's look at the perpendicular distance of a point from a line. The formula for finding the perpendicular distance of a point from a line is given as this. Okay, there is the formula to find the perpendicular distance from a line, of a point from a line. So we want to find the perpendicular distance of a point 2, 3 from this line. Okay, we'll write our formula down. The d equals to, okay, you have ax plus by plus c over square root a square plus b square. This is the x and y. It's 2 and 3 there. The line given to us is like the one on top. That is your a, x, b, and c. Okay. A is the coefficient of x, b is the coefficient of y, and c is the constant there. So you put everything there. 2 into bracket 2 plus b 4 into bracket 3 plus this c is 3 as well. Everything divided by the a squared there, that is the coefficient of x, which is 2 square, plus coefficient of b, which is minus 4 square. Okay, so the d now is equals to 4 minus 12 plus 3. You have this one to be equals to the 2 square is 4 plus the minus 4 square is 16. So we now have 4 plus 3 is 7, 7 minus 12. So you have minus 5 divided by square root of 20. So in this case now, we have minus 5 divided by the square root of 20 is the same thing as 2 root 5. We can rationalize now so that the root will not be in the denominator. So we have minus 5 over 2 square root 25 rather. We times square root 5 with both numerator and denominator in order to rationalize. This one is in sort, minus 5 root 5 over 2 root 5 times root 5 will give us 2 times 5, which is 10. So we can cut 5 here 1, 5 here 2. Your final answer should be minus root 5 rather, over 2. That's the final answer for that. Let's look at intersecting line. We find a point of intersection of the line, this and this. This is a simultaneous equation. When you have to find the point of intersection of two straight lines, just to solve the simultaneous equation, whether by using elimination method or substitution method, and get the value of x and y. It's just as simple as that. Okay, 2x minus 3y is equals to minus 1. This is for the equation 1. For the equation 2, we have 3x plus 4y. We just rearrange that. It's equals to minus 2. So we solve the two equations simultaneously, but we shall use elimination method on our own now to do this. Okay, so let's look at the illustration. Suppose this is the line 2x minus 3y plus 1 is equals to 0. And the second line, we have 4y plus 3x plus 2 is equals to 0. Both of them are on a Cartesian. We'll see that the point of intersection for the two lines is that, yes, we'll now trace this one to the x-axis. That's the x we are looking for. And the y, we trace that one also to y-axis. That's an illustration of that. Suppose we want to use graphical method. But in this case, we are going to solve it by elimination method, and we are going to get the same answer. By using elimination method, okay, let's say we multiply equation 1 by, we interchange the coefficients in order to get the same thing. We want to get 6. So equation 1 here, now we now multiply by 3. That is the coefficient of x in equation 2. Okay, so everything there multiplied by 3. You have the 6x, 3 times 2x, 6x minus 9y is equals to minus 3. Then we also have equation 2 multiplied by 2. Also, that's coefficient of x in equation 1, which is also 6x. Okay, plus 8y is equals to minus 4. They are now the same thing now. To eliminate x now, we subtract equation 3 and 4, the new equation we have now. Okay, if we put minus here, that 6x minus 6x becomes 0. So we now have minus 9y minus plus 8y. So minus 9y minus 8y give you minus 17y is equals to minus 3 minus minus 4. Don't forget we are subtracting equation 2 from equation 1. Minus 3 minus minus 4 will give us 1. So y is equals to 1 minus 1 over 17. We'll substitute this into equation 1, for example. We can substitute in equation 2 as well. We'll get the same thing. 2x minus 3. Anywhere we see y, we are putting minus 1 over 17 there. Okay, it's equals to minus 1. So now we have the 2x. We have the 2x plus 3 over 17 in this case. Minus 3 times minus 1, you have plus 3. It's equals to minus 1. So we can multiply through by 17. So you have the 17 times 2x plus 17 times 3 over 17 is equals to the 17 times minus 1. So you have 34x. This one will cancel. You have plus 3 is equals to minus 17. So we collect like terms. Take this one to the other side. Minus 17 minus 3 minus 20. You divide everything by 34. Okay. This one cancel. You have the x is equals to, we cut this. We can have 10, 2 can go there. You have minus 10 over 17. Okay, and that's for your x. So we have gotten the x and y now. We have gotten the x and y. So the final answer for this, since we are at the point of intersection, so the solution is the x and y. Okay, the x and y coordinate now, let's put them. So we have the x to be equals to minus 10 over 17, comma, minus 1 or over 17 as well. This gives us the final answer. Do not forget to like, subscribe, and comment. Thank you.